sweating. Oh, no. Okay, I'm ready. Disclaimer. Disclaimer. Oh yes, Clicky, you look amazing too. Oh, thank you, Click. I know I look amazing because I look just like you. Oh my god, Clicky Wicky, you know just what to say to make me all blushy. Oh, and then there is a baby. Welcome to Click Academy. So, have you ever been bored in a biology lesson? Well, screw school, welcome to Click Academy, where it's always click-a-clock, and we learn so much. Our brains are becoming so wrinkly and voluptuous. Enjoy. And if you enjoy, remember to cry-be-wibey to the channel, because knowledge, oh yes. Am I like an educational channel yet? I hope not, because that would set the standard for educational material really f***ing low. Netflix is concerned about some of its users. Someone watched Shrek 357 times this year, according to Netflix.
I mean, I'd be concerned too.
Legend. Yeah, that's an intense-looking Shrek face right there. Maybe they just have, you know, their one account, and they say like, well, as long as you only watch this movie, it's fine to borrow my account, fam. It's fine. How many hours is that? Like, Shrek is like, what, 2 hours long? 1.5 hours? Something like that? Let's say it's 2 hours long. So that's a solid 700 hours of watch time. And considering, I'm gonna calculate this. Okay, Shrek length. What height? No. Movie. I'm just gonna go to a Wikipedia page. That's usually a good place. Shrek, Wikipedia. Shrek is based on real life stories. Okay, running time 90 minutes, so it's 1.5 hours. So that's 357 times 90 minutes. So that's a total of 32,130 minutes. Divide that by 60, and that's 535.5 hours. Assuming that we stay awake 16 hours a day, we divide this by 16, that would take 33.468 days to watch this. So basically, how many days? It's 364, right? So divide this by 364. They spent more than 9% of their time awake during this year watching Shrek. You basically spent 10% of your life watching Shrek. Oh my god. That is, I don't know if that's beautiful or if it's absolutely horrendous. Context, there's a poll with a question, 2 plus 2 times 2 equals, If you chose 8, you're either A, joking, B, 7 years old, C, bad at math. Edit, go to the replies.
This is 8. The answer is little Mao have fist bump.
Basic math lesson, kids. Multiplication and division happens first. And when you have multiple multiplications, you go from the left to the right on the paper. So in this case, you multiply 2 by 2, which is 4, and then you plus 2, so it's 6. That's how it goes. 16 divided by 2 times 2 plus 2 equals question mark. 2, 32. Oh, what a little rascal.
Americans and your correct education system, y'all never heard of the thing BODMAS in primary school? Basically, B brackets of simply multiplying the brackets with a number outside of it. D division comes third, me multiplication fourth, addition, subtraction, the answer is addiction. Okay, addiction comes fifth, subtraction, the answer is 2, the frick. Alright, let me do this in Paint. I don't know if this is an American school thing, but I hate that way of writing it. Okay, Paint. Here we go. Well, hello there, kids. Welcome to Click's Academy. So today we have a legendary mathematical problem that the internet is up in arms about. It's a very controversial issue. We have 16 divided by 2, and then we have parentheses of 2 plus 2 equals what? Oh my god. And then this beautiful person has a rule in mind, which is called BODMAS, that I have never heard of in my life, and I don't understand why American school systems do this. If I want to rewrite this in a pedagogical way that anyone can understand, which I think is just common sense, I would write it like this. 16 divided by 2, parentheses, 2 plus 2. Because this lineup makes it so much more clear what is actually beneath the division mark, right? This is the common sense way of writing it. And then it's pretty obvious that this is 8 times 4, which is in the parentheses, and this is 32. Astounding, right? It would have been 2 if you put an additional bracket here, because then it turns out to be 16 divided by 8, which is 2. So it's all about where you put the bracket. But all in all, just write the whole equation like a functioning human being. So I hope you learned something. Smash the like button if you want Click to replace all school. my god, the world would be even worse than it is today. The owner of this Chevrolet Bolt electric vehicle has done what no electric manufacturer has done so far, something completely logical. We always wonder why these vehicles weren't designed to use the energy that produces the spinning wheels to charge the vehicle's batteries. This man did it at home. It's a generator that produces a current which charges the batteries. No need to stop and charge the batteries at the charging station or charge the night at home. While the vehicle is running, it charges the batteries. Simple, elementary, my dear Watson. Alright, welcome back to Clicky Kitty School University. So today we are gonna do energy. Amazing. So we have this very fascinating problem right here. So basically, you can put it this way. If this is the battery of the car, right? There is a little law in thermodynamics that say that you can't just create energy out of nothing. So basically, if you use this battery to pump it into the engine that we will denote as E, and this energy that goes here is X, all right? The engine will then produce this thing right here, which is an energy that goes into the generator, which we'll call G, that then produces into the battery, right? But then, of course, the engine also has a little bit of spill, like, you know, friction, heat, all that kind of stuff, and just general inefficiencies in the mechanical stuff, mainly friction, and that goes out here, and we can call that Y. So basically what happens is that this battery produces X energy into the engine pumps out Y energy in friction, and X minus Y back into the generator, which then also has, of course, a loss factor that we would call like Z. So what actually goes back into the battery is X minus Y minus Z, which is then, of course, less than X. So by doing this, you would just run out of battery, depending on how much friction and inefficiency you have in the system. But if you leave this running, your car will just run out of battery. This is not charging anything. There are systems in cars that charge your electric battery, and this goes for practically any car, but they have a bit of more systems when the car is like a hybrid and stuff. For example, when you brake, there is a generator tied to the brakes that generates a bit of efficiency. When you roll, for example, downhill, and you use what, at least we in Sweden, call engine braking, that's typically a generator that kicks in and like brakes it, so when you just roll downhill you recharge the battery, and so on and so forth. But no, it doesn't work like this. This is just ludicrous. There's a reason why we don't do this. This would be like trying to hook like an electric wire to itself and expecting it to charge. It doesn't work.
Hey Christopher, is it alright if you can take care of my kids in your place again? I can pay you if you want.
Oh, you don't have to. I'll go ahead and watch over them, Miss Duffy.
So fluffy.
I just want the head pats. It's all about the head pats. Life gets better with head pats. We can draw a curve for this, all right? There we go, all right. So here we go, baby. Science time. So if we just draw a very simple graph here, let me demonstrate this. Welcome to Click Academy. So imagine you have a good old graph like this, and then you have like happiness, and then you have head pats. It goes like this. There you go. Source, trust me, bro. Dot for the attitude. Any questions, class? Didn't think so. Moving on.
Short-term side effects such as heart/brain inflammation, paralysis, and even death. I'm not willing to take that risk.
Boy, do I have some news for you about COVID long-term effects. How the turntables? Hi, welcome to the Click Academy. Oh, let me see here. You dropped something. Oh, it's your IQ. It seems to have broken. I'm so sorry. It's okay though. You didn't have that much to start with anyway. My God, the sass. Oh, the sass is real. I'm so sassy. I can't believe it. I'm so sassy. I have so much freedom with this microphone. Ow, my arm hurt. I freaking love it. I love it. It's so good. I can do squats while making videos. I can do everything at the same time. Because I am a empowered, quirky boss babe.
Please give me a huggy wuggies.
No, what's wrong with you?
Well, Snuggles notices your...
Sorry, I'm getting corrupted by some sort of demon, but I'm all here for it.
Furries, other furries. It's dead.
Graph time! Graph time! It's time for graph, time for Click Academy. Okay, so back to class. Here, you see, more proof about curve. And then it ends up over here, where there's a lot of happiness, and you just show that by making a little emoji, very happy emoji. Okay, so this, I don't know what I'm trying to do anymore. We're sorry. The demon you're summoning is unavailable. Your ritual is important to us. Please hold while we connect you to the next available servant of darkness. It's like the coffee morning demon. Wouldn't you just like to have an emotional support demon? Is that a new plushie idea I smell? An emotional support demon? Oh, it's like super cute and round and thick and very squeezable. And has super tiny wings. Let me draw this. Let me draw. Drawing time! Drawing time! So imagine, class, welcome to Click Academy. Here we go. I'm just gonna pen, size, Click Academy. And of course a smiley because everyone is super happy in school. So, today we are gonna sketch a plushie that is gonna be an emotional support demon. So what I have in mind is like a very thick body, right? Because it's going to be fluffy. On the back, it has two very small, cute wings. Okay, that's a wing, apparently. And like, how do I draw wings? Okay, those are wings. And then it has, like, super small, like, chubby paw-like things, you know? Like this, because it needs to have toe beans. And then the same thing here, so it's, like, sitting down like a teddy bear. Imagine, like, a mix between a teddy bear, a bunny, and a demon. And then it has, like, a cute little head. Holy shit. I think... Okay. And then it's like this, and then you simply add like a couple of cute eyes, you know, that has a little bit of reflection to them, and then it has like a little uwu face, and like, what kind of, and then you should have like cute ears, you know, ears that kind of hang to the sides that are big and fluffy, and then like, it should be red as well. Can I make it red? Is this red? I'm trying to go by text. Because I'm a bit colorblind. I hope this is red. I'm not even sure. Holy shit! That went a bit far. So something like this. This could be the emotional support demon plushie. What do you think? Leave a comment in the description today. So that concludes today's Click Academy. Amazing.
Please don't use calculator, use your brain. 50 plus 10 times 0 plus 7 plus 2 is question mark.
PEMDAS. Parentheses, exponents, multiplication, division, addition, subtraction.
There is no parentheses. You can't go by that if you don't have none. Oh my... Ask any gosh darn heckin' math teacher to go back to school. All you do is solve left to right. The answer is 9, so please go back to school.
It is okay to be wrong sometimes. Part of being human is being wrong sometimes. But it gets kind of comedic when you're so confident about your wrong opinion that you call everyone else a moron and you tell them to go back to school when you obviously never showed up for a single god-frickin' day. Well, good day, kids. Today on Click Academy, we're gonna do some beautiful math. So on this channel is always a controversial hellhole whenever I go through a basic mathematical problem. Once upon a time, I believe we did this problem. 16 divided by 2 times 2 plus 2, because I want to demonstrate why PEMDAS is a piece of poo-poo. Don't get me wrong, it's a perfectly fine rule to memorize mathematical operations in basic math, but it's not like a mathematical definition in itself, and I'm gonna show you why. So in this problem, for example, that we have, it's usually rewritten like this in any kind of coherent math. And this is very controversial because depending on how you interpret the problem, you get two different answers. But in reality, it's just 16 times 2, which is 32. That's essentially the conclusion of this baby. But PEMDAS, to me, doesn't really make a lot of sense, because if we backtrack here for a second, I do a new file. No, I don't want to save this. Okay, well, oh, damn, I need a title. Click Academy. There we go, beautiful. Let's say, for example, we have a problem that looks like this. 2 plus 1 squared. Oh my god, what is this? PEMDAS tells us to do the parentheses first, which means that we get 3 to the power of 2, which is 9, right? But what if we switch it around? Oh my god, what if we do this one first instead? Well, you will be shocked to realize that we get exactly the same answer. My point is that if you know how to rewrite things, you get the exact same answer with everything you do. The only thing you really need to remember is that multiplication and division comes before plus and minus. PEMDAS in itself is not a mathematical definition. End of story. Please go nuts in comments. Thank you.
In case you feel sad, pat, pat, pat. Oh my god, head pats.
You remember the curve we drew a couple episodes ago where you have the curve and it's like a linear, maybe it's even, is it exponential? Oh my god, we have to go to the bottom of this very serious issue. So welcome, kids, to Click Academy. Hell yeah. So if we have a curve, imagine it looks like this. And then here you have happiness, happiness, and here we have head pats, head pats. It goes like this. This is the new theory. It's exponential. So after you go past a point of like let's say 10 head pats, this just goes towards like infinity. So infinite happiness after roughly 10 head pats. I think this is like the advanced model of this mathematical formula, and if you disagree, I'll be a sad boy. Source. I'll be sad otherwise.
You have to respect other people's opinions.
Their opinion. 3 squared is 6.
It's literally 6. It's 6, y'all. I'm smoking. It's literally 6, but okay. It's 6, y'all. Don't understand exponents work, and it shows.
Don't be so confident and condescending when you suck! Alright everyone, let's bring out paint. It's time to do this the hard way. Hi ladies, gentlemen, friends, welcome to Click Academy. So today we're gonna do 3 squared apparently, because that's difficult. So 3 squared means that you take 3 times 3, which is 9. If you really want to do this really thick, you can also think of this as 3 plus 3 plus 3, which is 9. Thank you so much, Nobel Prize, here I come. Thank you for coming to my TED Talk. Try 9 times 9, that'll show them. 18? Bro, you don't have to tell me, I already know I'm right. Well, good evening, lotties, lurkers, and horkers. Welcome to Click Academy. So on today on Humanity... Thank you for listening to my TED Talk. Oh my god, I found like a science-y TikTok. Let's see how scientific this is.
This is what they want you to believe.
Oh, wake up already.
They want you to believe we are flying through an endless universe going 500,000 miles per hour.
Okay.
If you believe we have been going 1.3 million miles per hour flying with the Milky Way for thousands of years and not crashing to other planets, you have been successfully indoctrinated. This is absolutely impossible. Why does an asteroid burn up going ridiculous speeds, but the Earth doesn't?
Okay, so wait.
Do you know how stupid that is? You can't even see those speeds. How does the water on Earth stay level? NASA and all the space agencies have successfully
how does the water stay level? Okay, how can you hold the water glass on a train? The same thing, right? Okay, let's go through this bit by bit, shall we? 500,000 miles per hour. Well, that's relative, and I believe this number is probably relative to the Milky Way core, if I were to guess. All the speeds in the universe that you measure are basically the relativity. When you measure how fast your car goes, it's relative to the ground. When you measure how fast the Earth passes the sun, it's relative to where the sun is. Like, absolute speeds isn't really a thing in a cosmological perspective. There isn't one fixed point that you can measure with. So typically what you do is that you decide on a point that is the greater one. For example, measuring the speed of our planets, you can measure it around the sun. The whole solar system, you can measure it the speed compared to the galaxy core. Of course you can travel in space without crashing into stuff. Do you realize how much empty space there is compared to actual matter? It's like a bonkerous... Let me actually Google that. What percentage of the universe is empty? The universe is at least 99.9999999999999% empty space. Floating in this vast dark void are all sorts of different objects which astronomers call celestial bodies. Wow. Yeah, with that percentage ratio, it's not so impossible that you can travel through space without crashing into another planet. And also water staying level, well, that's because the water is traveling along with you at the same speed in the same direction. The same thing as you will be holding a water glass on a train. It only goes splooshy sploosh when the train slows down or accelerates, which means that you have a heaviness, or whatever it is in English. I don't even know, I did mechanics in Swedish. Tröghet! Which means that when you slow down or something, there needs to be a force applied to the mass for it to catch up in speed. That's basically how it works. You would only notice this when something slows down or speed up. Same thing, you don't feel the movement of the Earth because, you know, the ground you're standing on and the air that's in your face is moving at the exact same speed in the same direction. That's why you don't feel that kind of velocity. And also comets burning up in the atmosphere, yeah, they burn up because there is air. So it's creating friction. The air particles basically makes it very hot. But in space, it's vacuum. So a planet doesn't randomly get super duper hot by just traveling through vacuum because there is no matter to get frictioned against. So this is hilariously bad. It's so many gotcha moments that are just, I don't know, like 9th grade science. It's so good.
Let's talk about the sun.
Yes, please.
Apparently, It is 150 million kilometers away.
Yeah.
100 million miles.
Yeah.
And it burns around 10,000 degrees Fahrenheit.
On surface level or
which
something
is like
that.
close
probably.
to 6,000 degrees Celsius.
Yeah, okay.
I used to work at a steel company, okay?
Ah. Oh, I see where this is going.
To make metal, the furnaces burn around 2,000 degrees. And you can feel that heat from about, I don't know, 25 feet away.
Yeah.
So you're telling me that something that only burns at 10,000 degrees can be felt at 150 million kilometers. Does that make sense to you? Nuclear fusion, and they say it takes a million years for the heat to reach us. It wouldn't have dissipated a little bit over a million years? By the time it gets, I don't know.
It does dissipate, otherwise you would burn
Say
up.
a million miles away from the sun, it wouldn't have, you know, we'd be frozen. This place would be a fucking ball of ice if that was the case. It makes no sense.
Have you okay. So the point here, of course, that is easily overlooked is the fact that the sun is big. That's what he said himself, or did he just say it was far away? Anyway, the sun is really big, which means that it pumps out a bit more energy and a bit more radiation, heat radiation around it than a small piece of metal. And if you think about energy, like, you know, like heat in a three-dimensional space, if you have something this big emitting energy, it's gonna be pretty hot out here, right? But because it's a three-dimensional space, the energy gets more and more dispersed as further out you get. So you need a pretty big ball of energy to actually send it a reasonable distance. That's basically that. So it's bigger, which means more energy, which means that you will feel said energy as heat further away from the object because there is more energy per unit of space, essentially. I mean, for God's sake, you can have like a small piece of grain heated up to 10,000 degrees and you put it on the other side of the room and you wouldn't feel it because it's so tiny. Because, you know, the energy that emits from this tiny body will be so not dense after a pretty short distance. And of course, there's more to it than the sun, its fusion, etc., etc. But essentially, the bottom line is that a giant fusion ball that is 1,000,000 times the size of the Earth is going to emit more energy than a piece of metal. Click Academy, everyone. Hey, yeah. A bat and a ball are $1.10, and the bat is $1 more than the ball. How much is the ball?
How the hell did you get the second ball? There is simple wording, completed price 1.1, and then the bat is $1 more, simple math, 1 plus 1.1 is 1.1. So by fact, the bat costs 1, the ball is 0.1, simple as that. Maybe in the USA you got teached the other way. Teached.
Well, then the bat would only be 0.9. That's more expensive, wouldn't it? It's time for Click Academy to learn them oofs. So welcome everyone to Click Academy. Click Academy. So today we're gonna do an absolutely beautiful question. So the premise of this question is the bat plus the ball costs $1.1, and we can just denounce it as the bat as X and the ball as y equals to 1.1, right? Absolutely beautiful. The second equation we are specified in this is that the bat costs $1 more than the ball, which means that the bat, as we have as x, is going to be equal to 1 plus y, right? Because it's $1 more expensive than the ball. So how do we solve this? Well, the rule of math is that you can solve basically one variable per line of equation. So the nice little trick here is to put this x into this one, which is of course this part of the equation. So this means that if we rewrite the first equation with the x put into this, means we actually get 1 plus y again equals 1.1. Simplify this bad boy, and you are gonna get eventually 2y equals 0.1, which means that y, which is the cost of the ball, is 0.05. That's a pretty affordable ball. Heck yeah. Okay, so now we just put this y into the initial equation or something we have here, for example. It's probably easiest, which means that x is going to be 1 plus 0.05, which is 1.05. Absolutely beautiful. And do we check the premise of this? Yeah, it looks like the bat is indeed $1 more expensive than the ball, and combined they are 1.1 expensive. Thank you so much for showing up to Click Academy, where I do weird things in Paint. Moving on. I can do this professionally. I am doing this professionally. I get paid for this. I get paid for doing, like, I don't know, 9th grade math in Paint. Frick yeah.
Big surprise! The corrupt CIA won't release race crime data this year. I wonder why, funky smileys. Want some facts? I bet you do. Whites average the top 90% of intelligence. I've shown mine. Blacks not so much. Ha ha ha.
Ooh, we got a little bit of spice of racism in here. See where this is going. Good old theoretic science. Gravity is just a fairy tale with 0 experiments to prove its actual existence. How do mosquitoes fly if there's a strong force holding everything down? Why is it when you fill a balloon with 50% helium and 50% oxygen, it still floats? Some forms of rain clouds are so heavy if they landed on us we would die or get seriously hurt. How does those clouds stay in the air if gravity pulls everything down? Seems like my approach is way more scientific and repeatable in experiments. You know the laws of science, not theory. Click Academy time, booyah! Well, good evening, laddies, lasses, and lazos. Welcome to Click Academy. Our first experiment of the day is to show that you can indeed do repeatable experiments that demonstrate gravity. Cool. Now moving on to the next one. Alright, laddies, lads, and lasses, welcome to Click Academy. So today we are going to look at some beautiful science together. The first problem is if we have a mosquito with wings like this, and it has little eyes, of course, because it's a mosquito and it's very happy. So if this thing is flying and we have a gravitational pull down here, how on earth can it actually fly? Well, what a mystery. So let's figure it out together. The force of gravity is equal to g, which is a gravitational constant, 9.91, I think, on Earth or something like that. Feel free to roast me in the comments. And then we have mass 1 and mass 2, which are the masses of the two objects we're comparing gravity between. So in this case, mass 1 would be the Earth and mass 2 would be the mosquito. And then we divide this by the radius squared, basically the distance between the two bodies of mass. So in this case, if the m2, which is the mosquito's mass, is kind of tiny, the whole F is gonna be kinda tiny too. Makes sense, right? Multiply by m2, tiny ass mosquito, tiny ass gravity. Which means that for the mosquito to be able to fly, the force upwards when it's flapping its fat little wings has to be at least F as well. Which of course, counting that air actually has a certain density and that kind of stuff, it doesn't take too much flapping to make up for this when the m2 is very tiny, right? So the fact that a mosquito can fly despite there being a force downwards isn't particularly far-fetched. Why is it when you fill a balloon with 50% helium and 50% oxygen, it still floats? Well, if you do indeed have a balloon like this, you can have a force upwards and a force downwards, and as long as this gravitational force is roughly the same, you know, it's going to heckin' fly. If it's the exact same force, it's going to stand still mid-air. It floats because it's lower density and everything around, the same kind of logic when something flows on the water. Imagine you hanging a rock in a rope underneath a boat. That's basically the same philosophy as you know, a balloon, only that one happens in air and one in water. It's all about having some kind of matter around it that has a higher density than whatever is inside of this one. So as long as you have a mass that can actually expand this balloon, you know, because, you know, if there's nothing there, it's gonna smack down. You're not gonna have anything that can float. So as long as you have something that can fill it out, but still have lower density than everything around it, it's going to give you some kind of floaty force. It's kind of nifty. And then the last one, if clouds landed on you, you would die because they weigh a lot. I mean, sure, all the air in the atmosphere weigh a lot too if you combined it all, but that doesn't mean, you know, there's gravity and density and very low density, and it's not like a solid object that's gonna smack into your face. I'm not gonna... Click Academy done for the day, we're done. Doctor, sir, the surgery has a 50% survival rate, but don't worry, my last 20 patients have all survived. Normal people, mathematician, This demonstrates the gambler's fallacy. It is the incorrect belief that if a particular event occurs more frequently than normal during the past, it is less likely to happen in the future. Yeah, that's very true. You can think of it as just a statistical tree, basically. Should we do a Click Academy? Click Academy? Paint! My favorite program, baby. Booyah! Good evening, laddies, lasses, and lassos, to Click Academy. So today, we are talking about statistics and the likelihood of things happening. So the most easy way to think about this is just a statistic tree that goes around like this. And to make it easy, let's just say it's 50-50 at each little 5-5, we'll call it. And for each of these choices, you go down the side, and basically you end up at a resolution. So this leads to the point that basically if something happens only on this side, for a long time, it means that people will think you will do the other option after a while, which isn't correct because at every single little point here, every single crossing you can call it, you still have locally, so to say, a 50-50 chance of anything happening, right? It is only when you zoom out and look at the whole thing as a whole that these larger statistics come into play, when you have 0.5 to the power or whatever. And that is how it works, so when you stand here and you're about to do the gambling thing, it's still 50-50. It doesn't matter how your coin has flipped before that. What your coin has flipped before that only matters if you look at the whole thing as a whole before you start, not when you stand at this specific crossing. That is what Click Academy for the day. My drawings are amazing. Pedagogology is very good, yes.
Hating on astrology is honestly rooted in misogyny, but I'm too tired to elaborate.
I have seen this go around a surprising amount lately. You know what? I decided to go down the little argumentative rabbit hole on this. Ignore what I said before about not arguing online. I am a hypocrite and I own it. Let's dig into this, shall we? Because I am entertained. 16 times astrology Twitter absolutely ended straight men. You see, now it's also about a men issue.
Dudes who angrily tell women astrology isn't real are still hurting from finding out magnetic bracelet don't make you better at sports.
What's it? That's... That's the gotcha. What about it's both just dumb? It's too silly, ridiculous. Why are you trying to make this like a gender war? Oh my god.
I think we can all agree the worst zodiac sign is men. I think we all can agree the worst zodiac sign is men. I think we all can agree the worst...
BuzzFeed, thank you. Very, very, very smart. Did you just try to defend astrology by making it like a gendered issue? What? And magnetic bracelets, get out of here. You want to have some fun. You want to have some statistical fun. Welcome to Click Academy. You think not liking astrology is misogyny because it's something that men don't like. You want to know a zinger fact of the day? The majority of women don't believe in it either. Is it what's it now? What's Is it misandrous now because the majority of women don't believe it? I mean, it's still an alarmingly high statistic if this is accurate, like, oh dear. But still, it's not a majority. What is this argument? It's just made up. You just picked one of the sides and be like, look, the majority of men don't like it. That must mean it must be correct or something like that. But the majority of women don't believe it either. What is this conclusion? I mean, messing around with the star signs or fortune cookies or any of that kind of stuff, you know, it's fun. It can be casual, fun stuff. You know, I have a couple of souvenirs with star and signs on them. It's cutesy stuff. But when you come with me and say like, oh, we're not compatible in the dating sphere, I mean, the fact that you would use it as an argument, it probably means that we aren't compatible in the dating sphere. But still, you know, it's it's not a magical personality trait. It really isn't.
But what most of you don't understand is that mankind's population is decreasing tremendously. 8 billion, but we could eventually be extinct, believe it or not.
The birth rate is decreasing. The population is currently still increasing.
How's the population increasing if birth rate is decreasing, Lemao, question marks? Where is your logic in that? If birth rate is decreasing, then obviously population is decreasing. If you look back, it's been decreasing since the 70s.
Slows the car down a little on the highway. Oh, poo, we're going backwards. I can actually explain this with a nice picture. Time for Click Academy. You have homeschooling and then there is YouTube schooling. This is actually a concept that you can read about in a book called Factfulness, really good book. But think of it this way, for example. Here are all the babies in the world right now, right? And each of these babies represent X amount of people. Here are all the young adults right now in the world. Something like that, absolutely beautiful. And up here on the next level, you have like older adults, which are now currently only one person representing it. And up here, you have the elderly population that I can't draw for some reason. Poor elderlies, I am sorry. So what happens that even if the baby rate stagnates, it means that this pyramid of ages still has to fill up. So like in a few years, in one generation, you will have one more person here, because the whole pyramid will have moved up one step, basically. And the birth rate is still constant, so it will still be 2. And in yet another generation, we will have one more person up here by the elderly population, but still the same amount of people here. Hence the theory that the population is going to stagnate around, I think it is 11 billion is the current projection. A couple of years since I read up on that, but that is what I know so far. But it's a pretty smart way of this like projection of the human population. At least that's where it's heading right now. So there you go. Yay! And basically the stagnation point, which is here, is when the entire pyramid is filled up with representatives of, well, the same amount of people in every age category. When that has happened, that's when the population stagnates, essentially.
Yay.
If the moon is 250,000 miles out in the darkness of space, how is it possible for there to be blue sky behind it?
I've never thought about that, to be honest.
It's a conundrum, or we should question the narrative more. I'm so sorry for your public education. Mine wasn't great either. Neither was your dad's. Homeschooling wasn't really a thing, though, at least as I remember.
Oh, yeah, because homeschooling would have fixed this. Oh, no. This looks like the kind of mom that says you shouldn't believe everything you see on the internet. You know, like Facebook memes about the moon. Science. All right, let's bring it in, shall we? Oh, yes, indeed. You know, public school might be crap, but at least we have Click Academy, isn't that right, Demon Boy? Oh, yes, indubitably. Hello, everyone. Welcome to Click Academy. I'm Professor Click, name unrelated. I totally don't own this company. So how does light actually work? If you have the moon here, and we're standing down here as a little Poe, and here is the sun. It's a scale 1 to 1, don't worry about it. You are as big as the sun because you glow so fine. Light is actually particles, so you only see something if there's something for the light to bounce off of. Light that goes this way, you know, it doesn't bounce off of anything, so it just keeps going. Light is only the photons captured by your eyeball. And the blueness in front of the moon is probably because there's an atmosphere right here. So, you know, you will see the atmosphere, but it's also kind of transparent. So here you will see the moon through the atmosphere, and then also this side will be dark because there's no light coming of this that's reflecting back that is big enough for you to register. There we go, absolutely beautiful. I hope we learned something today. Now I can mark this video as educational. If y'all think it's 16, try again. Viral math problem. 8 divided by 2 times the parentheses 2 plus 2. Oh, it's this thing again! This has a reoccurring cycle. Once every year. It is amazing.
It is 14. I'm tired of people not knowing basic math.
But I think the argument is that it's either 1 or 16. I haven't controlled it, but that's basically what I remember. And it all depends on where you think the division mark is. Let me bring up paint real quick and go to the paint. Sklabadaboobilagorban, welcome to Click Academy. So today, ladies and gents, we are gonna do the good old problem, which I completely forgot. What's the problem? The problem is this. 8 divided by 2, parentheses 2 plus 2. So it's 8 divided, by 2 times 2 plus 2 equals what? And there are two different ways to write this equation, which is why it is so confusing. The way it's written here means that you go from left to right and do the parentheses first, because multiplication and division have the same priority. Screw you, PEMDAS, you don't take into consideration that they have the same priority. Yuck! Anyway, that's one portion of the conclusion. So basically, if you do the parentheses first here, you'll have 8 divided by 2 here, and then you'll have that times 4. So 8 divided by 2 is 4, and then 4 times 4 is 16. Like that's basically how it's done with correct proper math. But there is a level of confusion depending on how you interpret this little baddie right here. Because you can interpret this as the 2 being multiplied first here, which is weird, but a better way of writing this, which is how you will interpret this math in like any higher math course, is that you have the 8 and then you put whatever it's divided by beneath it. So like this, which is basically the same way of writing it, but it causes less confusion because you see that the 8 is specifically divided by the 2. You can even put that in parentheses if you want to, which is a better way of putting it. Now another way of doing it, which is causing the confusion in this specific problem, is that you have 8 divided by 2 parentheses 2 plus 2, which would give you the answer 1. So the whole problem is this little doozy right here sucks butt, and everyone is confused by it, and even with some calculators, they will give you 16 or 1, depending on how the calculator chooses to recognize this. In my mind, as an engineer, this right here is the correct way of doing it, but I've heard people like that have weird rules for this stuff, so I don't know, I would argue this. Anything else is weird. I am correct. I'm so glad that I have the final say on my own channel. I do hope you learned something, baby. Moving on to memes. SAT math problem. Question. A hammer and a nail cost $1.1, and a hammer costs $1 more than a nail. How much does the nail cost?
So easy for me, yes, 10 cents.
Isn't it 1.05 for the hammer, so the nail costs 5 cents? Yes, that is the correct solution.
Well, the hammer plus nail is $1.1. If the nail is $1 less than the hammer, it would be 10 cents.
And then comes the beautiful twist. I think we've had this math problem in another video, but look at the top! Man thinks he's smart, saying it's 5 cents, posted to r/confidently correct. So you doubled down by calling the person with the right answer stupid? Alright, let's do this together, shall we? Because this is a bit of a trick question for the specific numbers used. I figured, let's do a little bit of Click Academy paint! Woo! Well, Click Academy. I basically have a PhD because my writing is basically doctor. Alright, so the rule for equations like this and solving them is that every separate equation you have can solve one variable. Unless you count parameter solutions, but that's a bit above the top for this specific problem. So we know that a hammer and a nail, we can call it H plus N, right? Hammer and nail is costing a total of 1.1. And then we know that the hammer costs $1 more than the nail. So the hammer is going to cost $1 more than the nail. So the hammer is basically 1 plus N. Right? So these are the two equations that we are given in the initial part of the problem. So the best way to solve something like this is just to put one equation inside of the other. So in this case, I would argue that we put the H inside of that H. And we know that H is this part, which means that we essentially put this part of the equation up here instead. And what we get is 1 plus N is 1.1. And with some simplification here, plussing the n's together, moving the 1 over to that side means that we have 2n is equal to, running out of space, 0.1. So n is equal to 0.05. Excellent. And if we put this n back in one of the initial equations, means that we have h plus n equals 1.1, which of course means that h has to be 1.05. And if we put this n back in one of the initial equations, we can easily break out what the value of h would be, which also means that h would be equal to 1.05. That is how you solve it, and if you want to check that the answer is actually correct, you can try putting both of these numbers that you now extracted into the initial equation. So you would get 1.05 plus n, which is 0.05, and that is 1.1, so it seems to be correct and in appropriate line with the equation. So a lot of these questions are written as trick answers. You know, it's 1.1 for a reason because they're talking about $1 difference, and your brain will automatically assume that 1 is gonna be part of the answer, but it isn't. So writing it like this in a concise way and then double checking the equations with your final numbers is a glorious way of doing it, because if you do this on your own math test, you will actually be able to confirm that the answer is correct without even, having gotten the test back. If you put your numbers back in the initial equation and it adds up, you have the right answer. So, yay, math life hacks with Clicky Thicky. Next meme.
I just need someone to explain to me why airplanes don't board back to front.
Not when you stand up, you press down harder, so you weigh more standing up. Wait, what? You don't weigh more standing up, but your weight is spread out over a smaller surface area, which applies more pressure. It's true, people weigh more standing up. Okay, I'm gonna go into a couple of different things here. Whiteboard! La 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 la, it's time to Click Academy. Oh god, we have a lot of poo-poo here. I'm gonna need like some kind of cloth for this. These are beautiful names, by the way, that helped me donate to the Trevor Project. You're all amazing, thank you. I'm not erasing you because I don't love you. I'm erasing you for science. Welcome to Click Academy. So today, the question is, do you weigh more by standing up? Well, if you stand up like this, what I'm assuming the person means is that the pressure, which is the area, basically force divided by the area. Of course, it's going to be a higher pressure on your feet rather than your stomach, because everyone knows that you usually lay down on your stomach on airplanes. I don't know what the point here is. But if you want to get really specific about it, you can say that the closer something is to the core, the center of gravity of Earth, the more gravity it's going to have. So technically standing up is going to reduce your gravitational pull on your head. So technically you will weigh more in that sense if you actually lay down, but of course it's so ridiculously small numbers that no sane person would ever calculate that. So that's why you board airplanes from the back, because if you lay down on your tummy in the airplane, you weigh like 0.000000001% more. Great. You can actually think of the length of your body in relation to Earth like an integral. You can actually calculate it like that, but we're not gonna do that because this is absolutely ridiculous. For first grade math, stressed my son out, lol, literally impossible. A shape with 4 sides and 3 corners. Wait, what? How are you supposed to do? Oh wait, it's an open shape, right? It has to be an open shape. Okay, let's check the comments. Here's a comment. 1, 1, 2, 3, 4, 4, 4. Okay, there we go. Like this. Lol, I am lost. It's just an M. So if you count open shapes, it's pretty easy. But that's not the first thing a kid will think of, I don't think. So it's a pretty silly assignment.
Random BS. Curious definition for something that is just in front of your eyes. Cognitive dissonance activated. It's barely impossible to debate with an ostrich. I did my best, but hey, keep swallowing everything Daddy Gov serves you.
Oh, ostrich because you stick your head in the sand? Is that the diss? I think that's the diss.
And they think they're thinkers. Look at this meme I made. Rocks don't reflect light, neither does the moon.
You do realize the fact that the picture you posted of the rock being brighter on one side is literally the rock reflecting light. What do you think it is? You're shining a light on it that then bounces into your eyes. That's why it looks brighter. What do you think? You're literally posting a picture of... Alright, back to the whiteboard, baby. So if you have a body of something, say for example a big floating mysterious circle in the sky, and there's light coming here, the light will bounce down to your little eyeballs of you standing here down on the earth, right? Look at that. Wow, little peepee here as well. That's great. So this side, you can see, because here is where the light bounces off of it, right? The reason you can't see a black hole, for example, is because all the lights get sucked into it. Light is just particles and waves. This is also why, for example, you can hold up at least newer phone cameras to, like, for example, a dark place and let it take a photo for a little while. What it does is actually takes a bunch of photos, which means collecting more light, overlapping them on each other to get a more clear picture of something even though it's dark. This is the same kind of technology that, for example, different space telescopes use, but of course to a much more ridiculous scale. It's literally collecting light. That's what it is. Everything that you can see is reflected light. That's how it works. So you're thinking about a mirror, which is very, very reflective, but everything you can see is reflected. God!
If the Earth was a globe, water flows to the lowest point.
Oh my god! Holy I love this. I love this so much. Oh my god, okay, let's tear this to pieces, shall we? Alright, everyone. Here is Earth, and the reason why water isn't like this, here's an ocean at the bottom of the earth. The problem with this, of course, is that what tells you what is up and down? There isn't an up and down because everything is relative. If you're standing here on the earth, down is going to be here. If you're standing here on the earth, down is going to be here. And you're also Australian. Pet the kangaroo for me. And why is this the case? Because the center of gravity is here, which means that all the water will be pushed like this, and also the atmosphere and everything else. The only reason why you think this thing is a reasonable experiment is because you're holding like a basketball and being like, oh my god, the water drips off it. This proves the earth isn't round. But the problem is it's dripping down because the earth is underneath you. That's what's dragging the water. It's not an isolated experiment. Just like your brain is a bit isolated. This is absolutely beautiful. 8 divided by 2 times parentheses 2 plus 2 equals question. I have seen this one circulates the internet once every 5 months. God damn it!
I took 3 calc classes. It's 16, bro. I have 2 math degrees. It's 1.
I hate this question. It's disgusting. It's disgusting. We haven't had Click Academy in a while. Let's do it. Paint, please. My secret weapon for knowledge. Paint! You cannot spell paint without pain, baby. Booyah. Welcome, ladies and Click Academy. So today we have a classical math example that we have never, ever seen before. The example is 8 divided, which they use this sign for some reason because they're absolute troglodytes, 2 parentheses 2 plus 2. Isn't that just gorgeous? And they're like, wow, what could this be? The problem is that not a single sane person writes an equation like this. Dear God, because it's unclear and it's poo-poo. If you follow PEMDAS, for example, which I don't like because people always forget that multiplication and division is exact same thing. You can divide something by 2 or multiply it by a half. It's the same thing, right? The priority is the same. So if you use this for this equation, having something like this simply means there's a multiplication sign in between these two, right? So if you only write out this equation as it is, you have 8 divided by 2, which comes first, which is 4, and then you have 4 times 4 because the parenthesis is 4, and that's 16. That's the correct answer. If you want to write this as a normal person, as I would do if I was having any math class, I would write it like this, if you want to be more clear. Because another way people interpret this is have a parenthesis around it like this, which of course would only make sense if it's written like this. You know? Here, the answer is 8 divided by 8, which is 1, which is how a lot of people interpret it. So, my point is, write equations like this. No one writes it like this. It's a troglodyte way of writing it. It upsets me every time I see it. Thank you for coming to my TED Talk. Next meme. I should have a little soundtrack for this. Hold on.
Oh, Click Academy. We learn things that bring us great pain.
There we go, done. Give me my movie series. Netflix. Yeah.
Lol, algebra. We can see without math and magic that 0.999999 is still technically 0. What? Until it actually make a full 1, it is not 1. It is 0.99999, which is still 0.
Okay, would this mean that 0.5 is also 0? Oh, can I have half a banana, please? Yeah, no, that's still technically 0. Half a banana is 0 banana. Thank you. Good math. I mean, what you're talking about is something called, I don't even know what it's called in English. Gränsvärden. Limits. It's like a limit values. It's converging values. So imagine, for example, we can actually bring a paint for this. We haven't done a Click Academy in a little while. Let's bring a paint, shall we? I love paint. Welcome to Click Academy. So today we're gonna learn about stuff like that. So for example, you would usually write it like this. For example, lim, which is limus in Swedish. I'm not sure if we use the same kind of stuff in English. And then you can have, for example, n goes towards infinity, let's say. So if we have limus, when n goes towards infinity, 1 divided by n, which is a very similar example to what we have here, the larger n becomes, the smaller this number becomes. So you usually say that this converges to 0, because you can make this as large as possible, so this whole equation is going to converge towards 0. I mean, you can draw this kind of stuff as a graph and it would, like, you know, very, very slowly converge to 0, not quite reach it, but basically become infinitely close to 0 as we go towards infinity. So therefore you say that this turns into 0, because that's the closest mathematical... I still said mathematical! It's the closest, like, realistic conclusion we can come to, because you can always write a smaller number, you know? So this is how it works. So what they're arguing about is actually a thing in mathematics. It's just when stuff goes towards infinity. So if you read past, like, I don't know, high school calculus, I suppose, you will encounter this quite often.
If gravity existed, it would have pulled all the apples off the tree at once. Globers be like gravity. Look at this one apple falling, but like the other apples aren't affected by it.
Alright, baby, let's bring up good old paint for this one. Maybe we can just make it in Photoshop instead. Boom, baby. Alright, everyone, welcome to Click Academy. So today we have a science experiment. Think about having a little fluffy tree that looks like this. Okay, there's a beautiful tree, don't question it. And then we have a couple of apples in this tree. We'll keep it simple with 2 apples for now. Both of these have a gravitational pull downwards. That is basically mg, or the mass times the gravitational constant. This is going to be your force that pushes the apple downwards. And for this very simple experiment, we're assuming the apples are of equal size. And now, of course, the aspect that makes a fruit fall down is as it gets ripe, the little connector here to the tree gets weaker and weaker, right? Because for the apple to stay up, we need another force right here that cancels out the mg, which we usually call n. That's like the counter force to anything sitting on the ground or getting pulled down. When n becomes smaller than mg, that's when the apple falls down and hits the ground, right? So basically, when this one becomes smaller than the gravitational constant, you can say that this one snaps and then it falls down. So this has to do with when the apple ripens, not so much that gravity just isn't real for the rest of the apples in the tree. But not so fast, you're not getting away that easy. Welcome to bingo. So let's see now. I would say this just falls under bad science, because it's very confident in trying to debunk something while just ignoring everything else. It's like kind of cherry-picking science in a way. It's really funny. It's just ignoring everything that could explain it, even really basic stuff like, oh, when a fruit gets ripe, it usually stays less hard on the plant. You know, just ignore that. Gravity just isn't real. That's a better explanation. God damn it. Gravity doesn't exist. 9.8. Oh, they actually got the number right. Meters squared fall rate, okay, doesn't apply in water. No, it still applies in water. It's just that you have another force coming up from below. Oh my, it's the same argument as with the apple. Click Academy time. This pisses me off to an unreasonable extent. Oh my god, okay, welcome to Click Academy. Okay, wait, no, I have to write this proper. Come on now, calm down. Welcome to Click Academy. So, today we have this very interesting experiment. Imagine, for example, this is you. This is you, very happy. You're a happy boy because you're in Click Academy. Isn't that beautiful? You have a force pulling you down, and the force is equal to mg. Your mass times the gravitational constant, depending on which planet you're standing on, which in this case happens to be Earth. That is 9.8, right? The reason you're not falling through the ground is because when you're standing on the ground, the pressure you can feel on your little feetsies is another force pushing upwards, which is called n. right? This is the normal force, it's called in Sweden at least. I don't know what the frick Americans call it, but that's basically what you call it. And this is the counter force. You can think of it as, for example, what you see on a scale when you're standing on a scale. That is what the ground pushes on top of your feet to make sure you don't fall through the floor because gravity is dragging you, right? And the same thing would work in water, you know, probably further down into the water because you need to float, and hence you need to be further down into the medium until, you know, enough of your body in the medium has the same weight as the medium. That's how it works. This is like ancient shit, man. People figured this out thousands of years ago, and you're sitting on Facebook being like, anyway, let's get on with the bingo, shall we? That makes me happy, at least. Oh, added context, it doesn't follow that speed because water imparts drag. Also, this is an 11th grade explanation of Newtonian physics. Indeed, a correct description of Newtonian physics need calculus. It does, and it's the same thing as air resistance. For example, if you fall through the atmosphere with air resistance, you meet the point where you stop accelerating. You, as a human, or any shape for that matter, has a maximum speed at which it can travel through the atmosphere if you fall. Right? And that is because air resistance increases squared with speed. So at a certain point, the force the air resistance applies on you is equal to the gravitational pull, meaning that you're going to maintain the same speed once you reach that point. And the same logic here would apply in water. It's just like friction, basically. Number 6, incorrect. Differentiate this one. Okay, so we say the differentiation is 32 times the parentheses of 4x minus 7 to the power of 7. I can actually do this one. Maybe this is interesting for the squad fam at home, alright? Let's see, do I still have the Click Academy? Oh yeah, we do. So for this math example, we have y equals parentheses 4x minus 7 to the power of 8. So a differentiation is essentially how fast something changes. That is the best, like, pragmatic way to explain what a differentiation is. And you can type it, for example, as they did here, like dy divided by dx. In some instances, you will also write this as y prime. It depends a bit on the course and where you're at in math. So essentially, how a differentiation works is that we want to know how fast this whole equation changes, and that's how you calculate it. So what you do is that you start off with the internal differentiation, which is essentially this, what is inside of the parentheses. And the differentiation is how fast something changes. So the 7 is just 0, because a constant doesn't change. You know, it's just a flat curve if you were to plot it. 4x changes with the velocity of 4, because that's how steep the curve would be, y equals 4x. So the differentiation of this internal part is just 4. That's the only part that remains. Then you have the external differentiation, which is just the power. And what happens is that the 8 goes down to in front of this whole parentheses, and you get a minus 1 on the exponent itself, which means that we have it times 8 here. Okay, and then after that, this one remains the same, internal, so it's just 4x minus 7 to the power of 7, because we have a minus 1 in the exponent. And this, in turn, would equal 32 parentheses 4x minus 7 to the power of 7. And now you have successfully differentiated this little equation up here. Absolutely amazing little homework. Thank you so much for listening to Click Academy. And it looks like the person in the example did it right. Look, 32, 4x minus 7 to the power of 7. But this is wrong. The correct answer is 32, 4x minus 7 to the power of 7. Which is the same. Oh my god, I feel the pain of this. Find a roulette table that's hit black a few times in a row and put $50 on red. This isn't how statistics work. Please avoid gambling. By that logic, it's better to buy a car that's already been through an accident because it's less likely to happen again. If it's black a few times, then red is due. That is statistics. No. Okay, look, I think we need to Click Academy. Click Academy. Click Academy. Alright, I'm gonna draw a little table for this because I see this around a lot. It's a very basic concept, but I feel like people misunderstand it. So what this person misunderstands about a statistical tree like this, when there's 50-50 to get red or black, is that if you stand at the top before rolling anything, getting 2 reds in a row would be 50% and then 50% again, meaning that it's only a 25% chance that you get red 2 times in a row. What this person misunderstands is that they believe that if you roll red here first, this one is still gonna be 25% while standing here, which isn't correct because you're already one step into the statistical series, so to say. When you stand at this point, it's always 50-50 again. So just because you've gotten red on the first roll doesn't change the statistic on any of these ones individually in this tree. So essentially what happened is that the person has ended up in this part of the tree, right? And insisting that you should pick the black one because that will be more likely. But it's obviously still 50%. What happened up here in this part of the tree doesn't affect this one or this one. If you zoom out on the whole tree and trying to predict something, then you can say that getting this one as red and this one as red would only be 25%. But standing here means it's still 50-50. This is why the logic this person is trying to insist obviously doesn't work. And the example the other commenter made with a crashed car is very much the same. A car crashing twice, like from now, is kind of unlikely, but if it already crashed once, that doesn't mean it's more or less likely to crash again. Maybe even more, because statistically it would probably mean that the person driving it is more likely to crash. I suppose. But that's beside the point. Anyway, don't gamble if you believe this is how it works. It's probably not going to end well. Richard Branson's spaceflight cost about $1.5 billion. Instead, he could have given every American $1 million. Tax the rich. Well, Ladislas and Lassos, I do hope you learned so much doing this video. Welcome to Clicky Kitty University, where we learn stuff that is pretty obvious. So I do hope you enjoyed this video, and I will see you again next time, and have an amazing day at home, especially you, Jonathan. I'm looking forward to next year's shower as well. Take care, everyone, and I hope you have an amazing rest of your day. Mwah! Well, Lotties, Lassos, and Lassos, that's more knowledge than I think we can handle for one day, so let's round it off here. I do hope you have an amazing rest of your day, and I will see you in the very near future. Take care. Mwah.